Good evening, folks, and welcome to yet another Friday night of Clay Codes. And I'm here tonight with Lilli Blair. Butch Howard, our regular guest, wasn't able to join us tonight. And I thought we'd start out maybe with talking a little bit about what we're really going to build here. We discussed it last week, sort of in round figures here, as it's going to be a light that looks like a cloud with a lightning storm in it. But up on the screen, I've got an actual picture of kind of what I'm trying to build. So, what we're talking about, some sort of hanging lamp with a cord, a little box up here that's going to hide all the electronics that we're building and programming here. And we'll have a board of some type down here, and we'll have a couple of light bulbs off of it. These are some pretty bright 12-volt LED lamps that I found. And we'll make those flash like lightning. Then around this, we're going to have a ring supported by some sort of wire supports that looks like cloud, so that when you see this thing, it looks like there's a cloud hanging from your ceiling. And when it hears a loud noise, it's going to light up like a lightning cloud, like a cloud with lightning in it. Words are hard. I don't speak well in French or English.
So in that electrical box, that's just where our sensor and the microcontroller is going to go, right?
Yeah, and a whole bunch of other circuitry that we'll probably have to talk about. That's probably for next week, though. I think next week we should probably dive into how are we going to build, what's going to be in the circuit, how do we build that circuit. As I'm looking at what it takes to power these G4 lamps, we need a few layers of indirection. So we can't just drive them off of our little chip right away. It would burn it out. So we're going to put a relay in there, just like a relay you'd find in a car. It turns out automotive relays are the cheapest thing I can find, and I love it. They're cheap, they're plentiful, and I know they're durable. But the trick that I discovered with automotive relays is that the coil that activates the switch it takes too much current, and so I can't drive that directly off the little chip either, and so I have to put a transistor in there. There's something called the Darlington transistor that's really good about dealing with high current loads, switching high current loads and shifting them rapidly. So we can probably use that. And I actually think when I was looking at the capabilities of those transistors, that we might not need the relay, which is great because the relays are kind of bulky. They're I want to say the size of a flash cube, but nobody listening to this knows what a flash cube is. Cameras haven't used these things in 20 or 30 years. But they're maybe an inch square. They're just going to take up a lot of space in that box, and I'm not really excited by that prospect. So instead, if we can just use these transistors, it's fewer things we have to wire in. It's nice, small components, or smallish, and we can maybe keep a nice slimline box up there. We do have to fit a LED power supply up there, though, too, because that power cord, that goes to a wall outlet, and that's 120 volt AC power, and we need to convert that down to 12 volt DC for the lamps and to 5 volt DC for our chip. Our chip will not be happy if we try to drive it at 12 volts. I think we could safely drive it at 9. I'll probably drop it down to 5. I've got another little chip. I don't even know what they're called, but it's a little 3-pronged thing, and I run 12 volts in one side, 9 to 12 volts in one side. Ground comes out, and 5 volts comes out the other side, which is really convenient for our needs.
Gotcha. For the power cord, are you going to buy something online?
Yeah, we'll just buy it. I'll either order something, or most hardware stores actually have really nice supplies for building your own lamps. It's kind of crazy. If you want to get into building a light, feeling artistic, go to a hardware store, and they'll have different cords you can choose from and sockets and all this kind of stuff. And just hook it up. You can hang it from a chain. You can hang it from cool-looking braided cords. I was very impressed. I went into Menards last week for something else, and I took a stroll through their light section, and there were a lot of good choices for different kind of light cords that we could use for the base of a lamp. So anybody who wants to build this at home can build it to their own taste. They'll have a lot of options. And again, I will try to put links up to all this stuff on Amazon so that you can buy it. If you don't feel comfortable going to the hardware store to pick this stuff up yourself, you can buy it off Amazon. That'll sort of help support this effort too, because we usually get a little bit of a kickback from things that you buy off Amazon. The kickback is really small. I'm definitely not funding my vacation home off of this. All right. With that said, did you have more questions, or?
I think that's about it.
Okay. We talked earlier in the day too about, maybe trying to make this something that's more relevant to somebody who's just getting into programming and to electronics. Because when we started this up, the things we're doing, we're going at it hard, just like we do for our day job. And somebody who's just coming into this, like, we're hitting them with a lot. Like, there's this whole test-driven development. There's CI/CD pipelines. What's this C thing that we're programming in? It's a lot to get hit with right away. So maybe we should step back and talk about some of the basics that we're doing here too. Because you were telling me, Lily, this is all seems very new to you.
Mm-hmm.
So
Yeah, so I remember one of the most daunting things when I just kind of started playing around with an Arduino is how do you get the code from your laptop onto your microcontroller, and what does it do on there?
yeah, yeah, that is a daunting thing. Now, when you started out, you were using the Arduino IDE, correct?
Mm-hmm.
And what's the process like with that?
There's a blue button with an arrow on it.
Okay.
And you click it. I think you have to select your board first, and then it detects what's plugged into your USB port, and then, yeah, it's as simple as just clicking a button.
Okay. And was that satisfactory for you, or was that, did you feel like that was maybe hiding the magic?
It's definitely hiding the magic, but I think it's a good way to get started quickly, and then you kind of don't need to know all the confusing stuff. Which is a good way to start, yeah.
Yeah. I think that's fair. There is an awful lot of hoops to jump through to go from the code here in our text editor to something running on the board. If you want to actually get a list of all the things, if you are new to this, I'm about to show you something really scary. You might want to avert your eyes. But it's actually all stuff that you can learn pretty easily. It's pretty well documented. So this is the file that sort of turns everything into... well, that was the wrong direction. I was going to close that terminal, but then it closes the shared terminal. Actually, you don't have access to the terminal yet, so I'm not doing anything to your selection. If you just look over here at the code previewer on the right, I mean, this just keeps going. It's not fooling around. We have to define all these variables up here for different things. So we have to define the compiler for C, the compiler for C++, the AR, which is an archive maker, linker, which takes all of these compilers just take a .c file and make a .o file. The linker hooks together all of those .o files into a final program, and it links it with some libraries. Thankfully, we almost never need to use nm. nm, it looks at .o files and library files and then with .a, and it'll show you what all the objects are in them. We've got object copy, which after we link the executable, this program called object copy goes through and translates everything that's in there into something that could be sent over the wire efficiently to the microcontroller, and it strips out a lot of the noise. OBJ dump. Honestly, I don't know what that does. Strip, which takes out all the debugging symbols and a lot of other things that bulk up binaries we don't want. Ranlib. At one point I knew what this did, but I don't anymore. And AVR size, which you don't really need this, but it prints a nice little status report about the size of all the components that we're using. And this is just this up here. This is sort of like the base, something called a toolchain file. So at the day job, you see that toolchain file that we have to use, Lily. And it's not much longer than what I've just highlighted here. What else do we have down here? Oh, we've got... this one's sort of special. I have to tell it when you're linking. This is a special variable that says when you are taking all of the compiled C files and turning them into the final thing, add these commands. So this links to the standard C library. This links to a standard math library. And this links to a library that's just there to support our compiler. It contains the support routines that the compiler wants. Who knew? Here we're defining a bunch of files. These are like intermediate files that we're ultimately going to use. So the file that ends in .elf, this is the final program that gets made. .map tells us some information about how the code is laid out inside the program. .hex, this is the final format that's going to get sent over the wire to our chip. Our chip, by the way, is, I guess I can't really highlight it for you, but if you look at the little red thing sticking out of the box in the upper right-hand corner, the chip is the little black rectangle in the middle of the red thing. And we do things here like we add an executable. This is the ELF file. And now we make a bunch of targets. We have a target, the ELF file becomes a target. For that target, it has certain properties, so it gets exciting things like we say which microcontroller it is. This AVR MCU, we set it in another place to be the little AT tiny, that little rectangle. All kinds of fun other stuff out there. You can learn all of this stuff. You can get your tools to... But if you're using the Arduino IDE, and I'm not going to go through this whole file because it's kind of insane.
Did you write this whole file?
I did not. And maybe that's an important thing to talk about. Now that I have read this file, yes, I can write one of these. And in fact, at our day job, things like that test macro that we use to define all our test suites very simply, I wrote that after I went through this. But people smarter than me have figured out how to do C++ with CMake for the Arduino. And so I used the power of Google. I think I asked for AVR CMake or something like that. AVR CMake toolchain file. And there was a lot of stuff out there, but one of the ones that came up near the top was an article that a gentleman wrote about... He didn't give you the whole file. He just said, okay, here's each of the steps that you have to do. Here's the code that does each of those steps. And so I put them together in this file. And the first time I tried it, I was like, wow, that's a lot easier than anything I've ever done before. But we just add all these custom commands. And that turned out to be really nice. Just say, hey, what's the output? You know, this gives the list file. This gives the hex file. Then the actual command that you run. So this runs that object copy file and does all this stuff out here. You can say what it depends on too. So if you hit one of these, you tell it, hey, make me the hex file. It goes back and looks at all the other stuff. It says this one says it depends on the ELF file, which is up here, which is actually this executable here. So you say make me the hex file. It's going to go back up and it's going to make that executable. Pick up all that stuff. The one that made me the happiest. Let me see if I can find it. There's a bunch of complicated stuff up in here that I didn't understand real well. Uh, it was this one. It makes a target called flash hex file.
Mm-hmm.
Which, okay, this one here, our custom target. So this becomes a name you can make. You can type make flash dash, and our target name is Stormlight. So if I type make flash Stormlight, it'll go back and do all these dependencies, basically all these custom commands. It'll go do all of them in the right order to make this flash hex file. And there was something. Okay, yeah. It'll make the flash hex file. Flash hex file makes the actual hex file, which has that chain. But flash hex file is the actual. It uploads the binary, that hex file, to the AVR. That's the one that made me super happy. That I could just type flash-stormlight, and it would upload it for me. Because I kind of want that to be seamless. I absolutely hate having to. So those who didn't notice in the picture, I might be old. My beard has gray in it. And so I grew up on a text terminal, and so I'm just not a giant fan of having to use my mouse to. Oops. I meant to give you read-write access to the terminal. There we go. I'm not super happy if I have to use my mouse very much for programming. I kind of want to keep my keys on the keyboard. And so that doing the whole deploy through the keyboard was really great. And I've been in high-stakes situations working with embedded code like this before, working with the Arduino suite, in fact. And I found it so easy to click on the wrong button in the IDE. And none of those buttons in the IDE are destructive, but it's just frustrating when you have to keep pushing stuff to the keyboard to have to keep or to your device to have to keep clicking. So if I could just type the commands, it made me happier. And now you have way more insight than you wanted into the mind of a Unix graybeard.
So when we're flashing the board, how do you define which board you're using and which port?
Yeah. So the port was kind of predefined in here. It defaults to USB 0.
Mm-hmm.
And that's just because on Linux, the Arduino suite is, and the Arduino programmers are just naturally going to try to put themselves on USB 0. That's just the way Linux works. On Windows, they try to go to COM3. But we could totally set a variable when we did the CMake. We could set the AVR upload port variable, this thing right here,
Okay.
and say it's really on this other port. Because we might be in a situation where we've got multiple devices that we have to flash and they have to talk to each other. So we could have them all hooked up. You know, I could unplug stuff out of this horrible little rat's nest of wires and plug in more programmers down there. But the other way we specify that is we're setting variables up here in the CMake file. So this is sort of most things I see related to AVRs use the same variable, AVR MCU.
Mm-hmm.
But we could go check in that toolchain file if we needed to see for sure what the variable was. But there's an official list of names, and the compilers know those official lists of names, and they put those when you say. So this expands to something like on the command line. It's like dash mmcu equals at tiny 85, like that. And the compiler knows when it sees that, use these instructions and use these linking rules. That also helps things like AVR libc figure out what are the memory addresses for all the different registers that we talk to read from pins and to write to pins. That lets the compiler make the right choices about what addresses to use. and which memory maps to use. I think Butch brought that up after we went off air last week, that even if we don't have to manually specify a memory map on these like you might on an ARM processor, something somewhere is specifying a memory map for it. And in our case, our compile tool chain is doing that for us based off of that variable right there.
Mm-hmm.
All right. Should we write some code?
Yeah.
All right. So when last we were here in the code, our goal was to make the little LED, which is right there. It's really hard to see when it's not lit up. Think of it as the blank spot in that breadboard. We kind of want to make that flash like lightning. So I think the first thing we want to do is probably just make it flash.
That's a good start.
Yeah, so what we were over here, I will follow you, and maybe we'll let you drive a little bit.
Okay.
Um,
I just realized this file is called TED LED.
so it What a great opportunity to rename a file, but right now it's just going to stay TED.
It's fine.
And if you are following along at home and watching this later, you can go see the code that we have at the URL at the top of the screen here, our GitLab repo. Okay, so what's our first test?
I suppose we should define a pin for the LED.
Oh, yeah.
Right now we just have a failing test. We're just asserting the 0 is 1.
Yeah. Hey, let's do a make test to make sure this actually works. I was a clever monkey and wrote down which pin we're supposed to be on, by the way. Okay, we are failed. Excellent. And we could run the individual test suites instead of doing the make test like we always do.
Where are those?
It's test/test-stormlight.
There we go. There we go. Expected 0 was 1.
Yeah. Hey, let's maybe... That's a really good question. Where are those? Let's go take a look at... I'm going to steal control back briefly here.
Okay.
This is the CMake for our test suite. And so we added... I defined a variable here for the name of the test project, and it's test dash and whatever the project name is. Project name was Stormlight. We defined it there. And so I added that executable here. So we added an executable called Stormlight. And because this is in the test folder, that means the built thing will be in test/test-stormlight. So this is all that's involved in building the test unit itself. Other than we also have to say, hey, link against this Unity library and look in the Unity folder for your Unity library. All right. I will stop talking. I will turn control back over to you, and we can write a reasonable test. So we're on port. Our port is port D2. I'm sorry, B2. B is in bacon.
Our port or the pin?
Pin. Sorry.
Gotcha.
It's port B pin 2. So, but the variable name for the port itself is port B2. I could be really clever and look up some previous work. Just a second. Yeah, that's the word.
Gotcha.
I don't know that that's a thing we... So, when we did the Wolverine flasher, didn't we have... What was the first thing we had to do with the Wolverine flasher? Because you don't just get to automatically start writing to the pin, turning it on and off. You had to... we had to tell the microcontroller first that we wanted to use this for output. Which involves setting a pin in the DDD port in that case, because we were on port D. But in this case, we're on port B, because that's the only port we have. So it would be the DDB port. And let me just go look up the Wolverine flasher. Really does sound like somebody made the papers here in Ann Arbor. But let me look this up and see what did we activate. And again, if you're just new to programming, this is what we do to figure stuff out. We don't just have all this magic knowledge in our head. We actually have to go out and look at these things. We look at work we've done before. Okay, yeah. Okay, so the register itself, which is just a variable that we assign to from our perspective, would be DDR for data direction or something like that. DDRB. Maybe we should just make a note on this. And we want to turn it on. We OR the existing value, so it's OR equals. And then, remember, we have to do that bitwise value thing, the underscore BV.
Mm-hmm.
And the argument to underscore BV would be DD. That would be delta delta Baker 2. And then you'd close the paren, and that would be the right thing to do to turn it on. But of course, we want to test that it was turned on.
Mm-hmm.
So let me go.
I think first we should just test that it's set to an output mode.
Yeah. That thing. All right. And let me... get an appropriate view of how do we test that. Yeah, we had some complicated... This test is moderately complicated that we wrote.
Mm-hmm.
Okay. So the way you test this is you call whatever our setup function is. And then it's a test assert equal like normal, but it's on a uint 8. And the expected value is the bitwise value of the delta delta Baker 2. And the value that we're testing is delta delta Roger Baker ANDed, a bitwise AND.
This is
the single ampersand.
the actual value?
Yeah. Right, yes, this is the actual value. Underscore bitwise value. It'll be the same thing that's over on the expected side. Yeah. All right. And okay, I see you've already set that up to run. So I think we're ready to do our test run.
Yes, we will. We'll fail to build.
Yes, we will. Yes, we will.
But that counts as a failing test.
It does, and then you can hand it off to me to implement. That's fair. Oh, that did not fail where I thought it should fail. Oh, and that is because I remember we had to do this cunning thing. Just a second here. Oops, that's not it. So there's an include file we have to include in the setup program, or in the main program.
Mm-hmm.
We need to include, and this is a standard include, so it gets the angle brackets. It's avr / io.h. And in there, we'll need to make a fake one of those for our test.
Okay.
I don't know if you remember doing that or not.
I don't remember doing that.
Okay. Well, I'll tell you what. I have it right here. So I'll take over driving for just a little bit.
Okay.
And so I'm going to, in our test folder, I'm going to create a folder called AVR. And inside of there, I'm going to create a file called io.h. And we have to put our regular guard clauses in there. I'll tell you what, I'm just going to copy this whole thing in. The entire point of beautiful feature of GitLab I just discovered. There is a clipboard function button at the top of any view of a file, and if you just click it, it will copy the entire contents of the file. We are not the first people to cargo cult a file like this. Okay, so this is defining our BV macro. This is just a copy out of the actual file. In fact, all of this stuff is a copy out of the actual file. Except these were for port D. We aren't using port D, we're using port B. And
How many ports does that chip have?
just B. It doesn't have any other ports.
Oh.
I've never seen a port A on an AVR board, and I don't know if that's an internal reserved port or if they just decided that port A would be a problem for some reason. But the port that we use, the chip we used for the Wolverine flasher, and that occurs on a regular Arduino, has a B, a C, and a D. All right, I think that is sufficient for that. So let's try running this. Let's try running our build again. As we both keep hitting it. Oh! We forgot to in Stormlight.c we included that file, but we didn't include it in our test. So let me follow you again as you get me a failing test. Yep, we got an implicit declaration of a
There
function.
we go. Yep.
Okay, so I will take this over, and I will make this a happier build. So up here in Stormlight.c, I'm going to need a setup function. And because I don't really like implicit, declarations, and compilers don't like implicit declarations, we're going to make a Stormlight.h. Get our normal guards. And I think this only needs the setup function for right now, so we're just going to keep it there. Alright, so I have Stormlights defined everywhere. Well, that's better. Oh, I still have an undefined reference to DDRB. Huh. Oh, in our test, we actually need to tell it that DDRB is a thing. And it's expecting... Okay. That's a UNT8T. It's actually going to be expecting also a port D, or port B, excuse me. So those two things ought to make this happier. I believe that built. Implicit declaration of functions set up. Oh, I did not include Stormlight.h. I want to try a thing here. Let's see if I get away with this. We've always done that with the quotes, but I think we've told CMake that that's a standard library. It is. It is a standard library.
Nice.
Okay. So now we've failed. We expected 4, but we got 2. So that's on us. Having bad expectations of things will just lead to this. All right. And so over here in Stormlight.c, we have to do the thing, which I believe was Delta Roger Baker. We're going to OR equal it with the bitwise value of Delta Baker 2. It passed. Excellent. All right. Let's see. I want to... Well, I've got a green test. This is a great time to refactor a thing. So I'm going to do a little bit of git refactoring. So I'm going to move TED-LED.c to test LED.c. And I'm going to check the test CMake. Okay, I was good in there and said every .c file in here is part of the tests. Okay. Oops. Now because I changed the file name, I have to rerun CMake. So I'm going to clean that up. Just because I'm untrusting. Delete the whole folder and start over. And so we've built it. And we'll run our program. And everything still passes. Okay, that's good. Which means now I get to write a test. And I think what I want to test is that if I call the main function, that I'm going to turn the LED on. Actually, no. Well, let's do that for now, because I want to see if we can actually turn the LED on. That seems like really important. We might throw this test out in a little bit. But I think for right now, we're going to call the loop function, which doesn't exist yet. It's going to be a lot like our setup function. But it's going to be a very similar sort of test. But instead of Delta Baker 2, it's going to be port Baker 2. And we're going to look at port Baker ANDed with the bitwise value of port Baker 2. Boy, I feel LEDs come. I feel variables coming on really quickly. Oops, I didn't get all my parens closed. Alright, now my parens are happy. see what that does for me. I think it fails to build. Look at that, it
That's
fails
good.
to build. All right. I'm going to hand control back over to you.
All right. Let's make loop. There's that.
And so, Lily, is the code to write springing fully formed from your head, or are you doing the same thing I do, where you just sort of cargo cult what's been gone before?
A little bit of both.
Okay. And if you're following along at home, you're not familiar with that term. Cargo cult is when you copy something mindlessly without really understanding why you're doing the thing. But you know it works, so you're not going to fool with it.
Yeah.
Or you know it worked before. You don't actually know it's going to work now. But you're hopeful.
Okay. So in here, we're setting port B2 to something.
I think it's port B2 is a value. I think that's just the value 2.
Oh.
But port B is the variable that we're setting.
Ah.
I think we can just do what we did above. That or equal means turn on this bit.
Oh, okay.
The value
As a person
is
without a computer science degree, I understand a base 2 number system, but applying it to the real world is a little bit different.
yeah. I think we don't want Delta Delta Baker 2. I think we want port Baker 2.
Oh.
Yeah, because your background's in mathematics, isn't it?
Mm-hmm.
Mine's in physics, so I feel your pain. All right, so we've got 2 passing tests. Wow, doesn't this feel like a good point to commit?
Mm-hmm.
Oh, look at that. We've got our VS Code file is showing up. We're just going to leave that. We're going to leave that alone.
Add
I'm going
that.
to add that to a git ignore.
There we go.
Cool. Now, something we don't have yet is we don't have an actual main function that does all the things we need.
Mm-hmm.
I would love to flash this to the board and see if the light turns on like we want it to. Do we want to take a diversion from writing tests and go do that?
Yeah, I think so. I think it's always good to test on hardware as soon as possible.
Yeah, we've certainly been bit by that in the past where it did not build. Or it built, but it did not run on the board the way we thought it would. I believe on the Wolverine Flasher project even.
Yeah.
Okay, so main is going to include, well, it needs to include Stormlight. I don't know if it needs to do much else, to be honest. Void main, no arguments, because we're in embedded and there's no way to pass arguments. And what do we need to do? We need to do setup. While one loop. Whoops. Alright, that's the core recipe for an Arduino program. Kind of for any embedded program, but... Okay. Boy, here's the $1,000 question. Does that top level CMake do the right thing? Oh, that's interesting. So it'll go into the source subdirectory, but there's no CMake down there. What's the toolchain going to do? I don't remember how we solved this problem before, but somewhere up here there was the add executable command. There we go. Add executable. Oh, this is great. Okay, so all we have to do, our file gets really easy. Um, and, I'm feeling super clever and like I totally got this. So I'm going to try to be a smarter monkey than average, and I'm going to go and look at what we did for Wolverine Flasher. Okay. Oh, the minute you think you know what you're doing, that's when it's all going to go sideways. Okay, so we're going to use that macro we created, that add AVR executable. The executable is going to be the same name as the project. And then we just need to add all the things in here. And I kind of want to do the simple, stupid thing that we did for tests, where we assigned all of the C files to a single variable. I don't want to call it test source. We'll call it prog source. Then down here we can just say everything that's in prog source is part of our executable. Okay, at that top level CMake, I feel like there was a magic invocation for... Huh. Is that the top? No, that's the Unity CMake. Okay. Thought I'd really done it. Okay. Set final false. Okay, so if we do a CMake folder, let me do an LS up here. What do we have? Okay, we don't have any special folders for that. So we're going to do a folder called release, or let's call it, yeah, release is fine. And we do a CMake like this. And you see in that CMake up there on line 3 where I've created that variable called final. I think that means I can do this. It's a Boolean. And then do the dot dot, and I think it'll do the right thing. Yes! Okay. Yep, so it's going to create all these files that begin with Stormlight and have the microcontroller name on them. Those will be all intermediate files. It's going to burn it to USB 0. Oh, this could be very exciting. So we do make and make flash Stormlight, if I remember what we talked about earlier.
Mm-hmm.
It's always questionable, and we are on camera, so let's see what happens. It's building, and no. It is not having it with that TTY USB 0 thing. Okay. Well, this is where we need to figure out where our port is. I have a real shortage of things plugged in that are identifying themselves as USB devices. Got a lot of snaps. Nobody cares about snaps. Well, I've got a... Oh, that's my headset right there. That's not helpful. USB port 3. Oh, I'll bet that's port 3 there. Anyway, I'm going to pull this little board out, which actually didn't feel like it was seated. That might explain the root of maybe why things didn't work well. I'm going to run dmessage again. What do we get? Hey, look, a new USB device. That's promising. Fab ISP. Okay, let's try that make flash again. It's still really grumpy about USB 0.
Mm-hmm.
Okay, so... I haven't run into this before, so this is exciting. in a I don't know what I'm going to do next sort of way. Okay, I've got a folder that lists TTYs. Let's go into that. I don't know if you're familiar with the proc file system or not. Well, that didn't have the information I really wanted it to. I was kind of hoping I'd see some file out there that just was called USB or something like that. And that would have made my life really easy, because it would just tell me stuff about USBs. What I got instead was different. Well, there's a folder called bus. I wonder what that folder called bus does. Doesn't look promising. All right. So I think this is where we refer to the wonderful world of Google. And here in the wonderful world of Google, we're going to go have a look for. This is a. I think this is a SparkFun AT-Tiny programmer. Yep, SparkFun Tiny Programmer. So I'll just put that back in where I found it. Let's go see how that hooks up to Linux. There's our device, that's sure enough. And it would be really helpful if it just said, hey, this is the port it shows up on. Doesn't have that right here, but datasheets might. Let's go take a look at our datasheets. Tiny AVR Programmer Hookup Guide. There's our Tiny AVR Programmer. Alright, a lot of suggested reading. So, talking about all our pins there, that's really great. Lots of fun output programming pins. Driver installation. This could be important. You may need to set it up on your computer. If you're using a Mac or Linux machine, you don't need to install drivers. Just plug the board in and skip to the Programming in Arduino page. Okay, so programming in Arduino here somewhere. So everybody loves Arduino. Okay, so I am going to, and I have to do this off screen, unfortunately, or off camera. Fire up the Arduino IDE and get it to tell us all about the AT-Tiny. And tools. Oh, somewhere in here. Alright, it did say something about I needed to download a thing. So what I'm doing is getting my Arduino environment to tell me about AT-Tinys. Ooh, doesn't know a lot about AT-Tinys. And this lovely document mentions, follow the link below to get to it. You'll notice a lack of links. Alright, well, you know what? It says it's on GitHub. GitHub AT Tiny. A lot in the topics. I feel like this might... This doesn't feel like an official reply.
Yeah.
This feels like... Watch, he's totally the person who made all this stuff. Oh, this only just has the pin maps. This doesn't have any board connection information. And all I'm really looking for is board connection information. Alright, so let's just ignore him for a little bit. So, board AT Nano. Board info programmer. Bootloader. There should be a thing on here for finding my board. Or, more importantly, for finding my port. The port is what I care about. It is the only thing that I care about. Huh. Okay, well that wasn't helpful. Huh. Okay, well this is going to prove exciting. I think I have to go back and continue to read the manual. This is really a horrible state of affairs. We don't select a serial port. We do select a programmer. Oh. Well, this is fun. So it doesn't use a regular serial port. That means I need to talk to AVR dude about... So AVR dude's the program that does the upload. AVR dude, Spark Fun, Tiny Programmer. A lot of links to things that I've already seen. Yeah, like this. I've seen this before. Recently. Kind of wasn't what I wanted, so that's the hookup guide there. But I think that's just that document that we looked at. Okay. This tutorial might also tell me how to get the little beastie. Because all I really need it to do is give me the output from AVR dude. Or whatever other program it is, and we can just make a custom command.
Mm-hmm.
Okay, so this is the URL. Hey, that URL that I found was actually the right one.
Nice.
Okay. So let's go back into here, and this is in preferences. And I'm saying in here, you can't see it. And now I can go down here to boards, boards manager. I can ask it about AT-Tinies. There we go, David M. Ellis. Latest version is 1.0.2. We are installing it. Okay, it's installed. Now I go into board manager. Oops. AT-Tiny 85. That's our favorite little toy there. Now, according to this, I then go and ask. I ask it about. Oh, let's see. I'll bet I go in here now and it asks me about programmer. Yes, I asked it about programmer and it does not have the information I want. Okay, this is where I have to go back and read the stinking manual. Alright, we download the AT-Tiny add-on, which we've done all that. Open and configure the Arduino. Tools, boards, we have the AT-Tiny. Oop, I need to go make a very careful selection of boards. It comes with a warning about the processors. Okay, the clock. I have to use the 1 megahertz, unless I know what I'm doing. If I use the 20 megahertz, like the board will never work again. All right, and okay, like other Arduino boards, you don't have to select a serial port when using the Tiny AVR programmer. But you do need to select a programmer. Under Tools, Programmer, select USB Tiny ISP. Tools, Programmer, USB Tiny ISP. Alright, and I'm writing a tiny little sketch here. Actually, no, because it doesn't matter what I write. I just need to push it out. Okay, I plug in the AT-Tiny. Oh, what the heck. Let's make it do it. I actually don't know what pin I'm... I don't know what pin that is, that port B2 is in Arduino land. Maybe I should go look that up. AT-Tiny 85 Arduino pinout. Okay. This looks promising. That was less promising than I hoped. Significantly less promising than I had hoped. Oh, this is actually really convenient. So that is also port 2 on our chip. So very nice. Where was the code? There's the code. Okay. So I'm actually going to make it blink because why not? And right, so I'm just copying that program that's in there. Okay. Let's try it. Oh, I gotta save it. Interesting. Alright, let's try it. Oops, there's all my verbose commands. You can't see them, I'm sorry. It's lighting. Look at that. Okay, I'm sorry, you can't see it.
Very nice.
It is flashing. Okay, so it ran a command down here. And I'm just trying to get the Arduino IDE to divulge its command for me. Oh, it did not divulge the upload command. So okay. We're gonna try this again. Lights are gonna flicker. Okay, AVR dude did the right. That's what I needed to know. Okay, that's one of the things that I needed to know. Alright, I'm gonna copy the text of the command, and then we can dissect it, figure out how to make it really a thing. Alright, so I'm gonna go back to... Okay, we've got the editor. The fun thing is I can see the editor in the... There's the actual editor. What I couldn't do was actually see the editor in on my desktop. It was buried under stuff. I could see it in the stream, which is sort of surreal. And so there is all the stuff that we need. We've got the AT Tiny there. Let's see, USB Tiny. Oh, I think it's on. I think the port is USB Tiny. Let me make sure that's a comment, states a comment, and doesn't get brought up. So, like, all this stuff is noise. We don't need that. Whoops. AVR dude does the upload. Okay, that's our configuration file. We don't care about that. It's being verbose. -P AT Tiny. I think that's handled for us. The -C is USB Tiny. I think this is the command itself here. So, like, flash, write, name of the file. I don't know what the -I, or the :I stands for in the end. Not that worried about that, though. So, USB Tiny is... is our port, but let's go look in the toolchain file. If we look in the toolchain file, what does -C get used for? -C does indeed appear to be the upload. Oh, that's the upload programmer. -P is the upload port. Huh. There's no -P in our command. This is like completely different.
Mm-hmm.
There's a lowercase p, but there's no uppercase p. Lowercase c. What does lowercase c mean? Huh. Well, let's go search for that variable and see where it gets set. Ah. So it gets set to Arduino if it's not, and we need it to be USB Tiny. We need it to be that thing. All right, what was it called again? AVR upload programmer. So I'm just going to copy it. We're going to go up here. We're going to set it. And USB tiny. And hopefully that means sufficient magic to the other end. And no capital P on the end. Okay, so I kind of want to set another variable. I want this to be part of a variable. And so... what's a good name for that variable? Port command. It'll be empty. But if I use the Arduino programmer, not what I wanted. So port command to be that. And if AVR upload programmer equal Arduino, then we can set port command equal to that. Just do this, which might evaluate to nothing, or could evaluate to the port command. Okay, well that was very complicated.
Mm-hmm.
Let's rerun the CMake. Make flash, Stormlight, and we're over time already, I see. It did it! The light stopped flashing.
Oh, very nice.
Wow, cool. Okay. Now we know a thing.
Mm-hmm.
And we just modified that complicated file. That's really cool, actually.
Mm-hmm.
Well, I learned a thing. I had no idea how to make that little programmer work. That's really great. I should make a video about how to get that information out of Arduino, though.
Yeah.
Say, hey, I don't know how to use this programmer, so share the information with me. So I'll probably put that out in the YouTube stream rather than on Twitch. Maybe on Twitch. Who knows? Anyway, I feel like that should be it for the week, or for the night. We're at an hour 15.
Yeah,
Right.
I'd call that a win. We've got a light.
We have a light. It's doing the thing our program says to do about lights. Okay, this is a great time to make sure our Git status, or our Git stuff is in order. Okay, step one is Git. We need a Git ignore. It's just not... Oh, I wonder if I could just right-click on that thing and say add it to the ignore list. No. No, that is not one of my options. Okay, so... Oh, there is already a git ignore, so never mind. It's there. Oh, we already know to avoid the build and release folders. We're also going to tell it to ignore the .vs code folder. And suddenly it all got better. Okay. We can flash to the board. We'll push it. Still shows me something. Oh, I forgot to add all of that stuff.
Whoops.
Okay, so changes to flash to AT Tiny Programmer. And that's pushed. And I'll bet if we went out onto the thing to look, it would be there. However, I'm going to stop us for now, and we will go